Okay, so you may start when you're ready.
All right, let's get the pins. Okay. All right, hi guys. Our project or our group is Team Stunt Monkey. It's comprised of myself, Josh Bolding, Christopher Ramos, Gus Forrester, Daniel Dupreez, Lucas Tenery, and Dakota Esteen. It's where stunt riding meets data. And what is a stunt monkey? A stunt monkey is a Raspberry Pi based self-powered or self-contained power device that measures and graphs a rider's wheelie data. It allows a rider to graph and visualize their wheelie angle as it's happening live time and share that with other riders who have the same device. In our presentation, we're going to be going over the hardware required, the app that's interfacing with the device. Then we'll be going over the device in more detail as being the Pi. Uh, that'll be followed by a device demonstration by Daniel. Then we'll go and check out our website, stuntmonkey.tech, and then we'll wrap up with the financial side of things with Dakota. I'd like to now pass it over to Chris, who's going to go over the hardware requirements, the tech needs.
Thank you. So some of the hardware requirements we need are as listed, and their specifications are also listed. You need the Raspberry Pi itself, the accelerometer, and some of the general requirements are you're going to need internet access. You're going to need for purposes for this, it is only running on iOS, so you'll need an iOS device. So just some general hardware requirements, and there's a full list there. And then next we'll go over the software requirements. So here's different softwares that we were using when creating this project, Stunt Monkey. Some of the important ones were Python and Swift for use by our CS developers to program it. And AWS Cognito was used to allow user sign in and sign up for the application. And once again, this is iOS only. And so now that we're done with some of the software and hardware tech needs, we'll move it on to Gus, who's going to talk about the backup plan.
Thank you, Christopher. My name is Gus Forster. I'm the other IT person for this group. So, like Christopher said before, we are using AWS, and AWS comes with its automatic backups that we can configure to the time that we want it to and how often. So we're setting ours up for having daily backups for all our user data, and then on our CS majors, their code that they're using to actually have the app talk to our database to and from, we're using GitHub, as GitHub is where they're actually coding to actually talk to our database to the app. And then they also have a external hard drive that we're backing up twice a week, just in case someone accidentally deletes some data at the database that we actually need, or if the GitHub or hard code data is lost somehow. Next slide, please. And then onto our user manual and our device setup. So on our device, it's kind of directional. And so we have an arrow pointing on the final box to show you which way it needs to point to. Now, the mounting on the actual bike is up to the rider's discretion, because these people who are actually stunting on bikes have a lot of aftermarket parts. And so there's generally not a foolproof place to put it on the bike for some reason. On our application setup, as Christopher said before, we are only running iOS devices at the moment, as that's what we could actually set up with as of now. Later, hopefully, we go longer than that. And as long as you have an email that you have access to, you can do your email and password to log in. And I'm gonna give it to Lucas to talk more about the actual device in the box.
All right, thank you, Gus. My name is Lucas Tenery. I'm one of the CS majors in our project. And looking at the actual device, we decided to go with a Raspberry Pi Zero W. It's one of their wireless enabled models. So it has Wi-Fi enabled, which made it just easier for us. It's already built in. We don't have to worry about adapters. We're using an MPU 6050 accelerometer. It's also includes gyroscope and temperature gauge along with various other small sensors we didn't end up using. But we're using this accelerometer to track the coordinate plane and then taking those coordinates, the relative coordinates, and calculating the angles from it. So we're getting pitch and yaw from it, as well as roll. And then to kind of piece it all together, we have a weatherproof hard case that we have everything soldered together and mounted in. And then along with that, it has a USB rechargeable battery that just connects everything up and powers it. So it's really hands-free and easy to use for the consumer. And then on the software end, we decided to go with Raspberry Pi OS just because it's open source, it's easy to use, it's very versatile, which really helped in our prototyping phases. And then for the actual development, we used Python 3.9 just for the built-in libraries. Again, you kind of see a common trend of ease of use here. And we were able to get up and going really fast and figure out what we needed to do and how we're going to get it to work. So that's all I have for the hardware side. I'm going to pass it off to Daniel and let him talk about the software side.
Thank you, Lucas. My name is Daniel Dupria, and I'm going to talk to you briefly about the application, and then we'll jump into a live demo. So we wrote our app for iOS in Swift. We used Swift UI as the framework to make our user interface. We used Amazon Cognito to handle our user sign up and sign in. And then we also used an AWS Aurora database to store our actual ride data. And then we will get into a demonstration. I'd like to potentially, hopefully not, apologize in advance. We ran a test of this presentation a little bit before class started, and everything's working before and then during the presentation, everything broke. So hopefully that doesn't happen, but we'll see. Okay, so this is our app, Stunt Monkey. When you first open it up, you'll be greeted with our login screen. If you have a username and password, you'll sign in, but we don't, so we will sign up. We'll give a name and an email. And a password. We will confirm that, and then AWS is actually going to send us a confirmation email, which we have gotten here. And so we can confirm our email, and then we can then sign in once our email has been verified. All right, now that we have signed in, we will now pretend that we're out on a racetrack and we have a bike. This is going to be our bike. This is a Raspberry Pi with our sensor attached to it. We've just powered it on. We have our app, and we will connect to it. Maybe not. All right, we are connected. If we had ride data already stored on this device, we could refresh it here, but for now we're going to start a ride. So now we're currently recording a ride. We are getting data from the Pi, and you can see it graphed on the screen. And so if we did an example wheelie, I can move the device up, and we can see that our pitch goes up. I can also take it back down. We see it goes down. And then I can also take it, test our roll as well. And we can see this on the device in real time. If for some reason the device got disconnected, that's fine. The data is actually being stored on the Pi, so we could just get it later. For now, we will finish our ride and just click stop. And then we can refresh our on-device rides, and we can see that we've just recorded one. We can choose to either delete it if we don't want it for whatever reason, or we can upload it. So I'm going to upload it. Okay, yeah, and it has been saved into our ride history. I think this is just a visual glitch that it showed up twice, but it is on here. And we can see that we recorded for 39 seconds. And we can see our pitch and roll graphed over time. We could then go through and analyze this and see how long our wheelies were and how high the angle was and stuff like that. Okay, just to show you guys that we are actually using the cloud, I'm going to switch over to a different device and sign in with the same username and password that I just created. And we'll be able to see the ride that we just recorded. All right, so I am now on my iPad. I'm already signed in with a test user, but I can sign out, and then I can sign in with the username that we just created. I am signed in, and if I go to my history, here's the ride that we just recorded. Again, it's nice being able to use this on the iPad as well because the screen's bigger, so we can see more of our data at once and get a more in-depth view of how we actually performed during our ride. Now I'm going to pass it over to Josh, who's going to show us the website.
Thank you, Daniel. Switching over to sharing. All right, and here is Stunt Monkey's website. It's stuntmonkey.tech. This is basically just our little business card online. It's a simple page. We have an about, a little contact form, and then our e-commerce part of the page. So we have a listing for a Stunt Monkey device or Wheeliometer version 1.0. For this module, we're using WooCommerce. And for the payment processing, we're using Stripe. So I wanted to demonstrate a transaction. So I'm going to add one to cart. And it's been added properly. View cart. And we could set our shipping or tax details here, totals. Right now, subtotals 50, free shipping. Shipping's estimated to my house. Please don't send anything there. Proceed to checkout. And I've already got my billing details in. Continue. Continue on comment. And then for this, we have just a test number set up to demonstrate it and to make sure everything's working. We can use just whatever expiration and CVC here. And everything looks good. We'll place the order. I'm waiting on Suddenlink. And then order has been received. We get our order number, the date it was processed, the payment method, just the order details, and you'll receive an email, the one you set up in your billing detail that confirms the order, and the status of the order will update as it gets updated from processing to pending or shipped. You'll receive a notification email with that as well. And with that, I would like to pass it over to Dakota, who's going to go over the financials.
All right, hi everyone, I'm Dakota Estine. I'm the other CIS major in Stunt Monkey, and today I'll be going over the financial aspects of our project. So diving right into the balance sheet, you can see that we have set aside $100. We have $350 in accounts receivable. This is from selling 7 units at $50 each, which is our price point. We have an additional $250 in inventory, or 5 units. And dropping down to equipment, you can see we have $30 in equipment assets. This is just like our soldering iron and other tools that we can use to assemble each Stunt Monkey device, nothing too complicated or fancy. And on the other side, we have our current liabilities. We have $560 in accounts payable. This includes costs of unpaid for advertising and parts. Under that, we have deferred revenue at $50. This is an example of if one person bought a Stunt Monkey device and we haven't actually delivered it to them yet, but we still receive that money. And under that, we have short-term liabilities at $120. This is including the Apple developer fee and our other paid for advertising expenses. And dropping down, you can see our total assets equal $730, balancing out our liabilities and shareholder equity. And on the right-hand side, we have our income statement. Starting off with revenues, we have our sales of $350 minus our cost of goods sold. And we were able to calculate each price of each unit at $24.10 per Stunt Monkey. And subtracting that from the sales, we grossed $181.30. Next, we have our operating expenses, which include advertising, website hosting, and the Apple developer fee, totaling $196.62. And we were actually at a loss here on our operating income at $15.32. However, our other revenue, which included ad revenue from the website and ad revenue from the mobile app, actually put our net income to a positive of $20.20. So next slide, please. And next we have our quarterly analysis. We have a growth projection in sales. So what you see here is Q3 of 2021, and then a projection of Q1 of 2022. So at our cost per unit of $24.10 and sale price at $50, the first month we went into sales, we averaged 2 units per month, and the next month another 2 units. However, we spiked up a little bit and sold 3 units the first, and using a 95% confidence interval, we can see our projected growth in sales. And so lastly, I'd like to talk about, so what would we do with investment money? And as you can see here, this is just our sales without any sort of investment help. And if we had investment money, we would initially just throw that money into advertising. We have a brand new product that there's not one currently on the market. So we need people to actually get to know what we have. And that would be from either online or advertising, or my personal favorite, which would be actually going to these events and selling to our demographic hand to hand, like pitching a tent and selling these products and showing the communities what we have to offer. And with that being said, we conclude our presentation and opening up for questions.
I had a question. So based on the app, you had to input your device's IP. So I assume the device has to be connected to the network, correct?
So I'm at home right now, and in order to connect my phone to my Pi and then also stream it to Zoom, I am connected on my own network. But if you had this actually connected to a bike, your Pi would start up its own ad hoc network, and you would connect to that through your phone and then interact with your Pi and then upload the data through your cellular connection, since you're probably not going to have Wi-Fi out on a racetrack anyway.
Okay, that makes a lot of sense. Yeah, because that's what my question was about. Like, what would happen if you're biking and then in the middle of nowhere?
Absolutely, yeah. Since the Pi has a Wi-Fi chip, then it can make its own Wi-Fi network.
Okay, why are you using Wi-Fi rather than Bluetooth? Bluetooth would save you on battery.
Wi-Fi was easier for us to do just from like a prototype perspective. Once we had like a final product, we would probably switch to Bluetooth.
Okay, and your MPU 6050 accelerometer, does that require calibration?
I can actually talk about that. It doesn't require calibration, but in the code we have a calibration setup. So when the Pi is actually turned on, it zeroes out. Just because we wouldn't know based on the device how it was angled or how it was set up properly. So just when it turns on, it zeroes out initially. So that's at your set point, and then it can check the angle from there.
Hi, I had a question. Why even use the Raspberry Pi at all if you have to use the app? Why don't you just use the phone and use the accelerometer on the phone that you have to have nearby anyway, it seems?
I'll answer this if you don't mind. As more of a scalability issue, this is just a prototype, and we want the future product to be able to do other things, interacting with the bike. checking temperature, speed, and various other things. So yes, you could just use your phone for this, but the phone doesn't scale as well as a Raspberry Pi would.
I had a question. I was wondering, how did you guys get to your price point and kind of land on that being the how much you guys are going to sell your product for?
Yeah, I'll take that one. So we had landed on a $50 price point just on interacting with. I'm the one stunt rider in the group. So I talked to a bunch of my friends when I was out riding in Dallas and in Houston, and just a couple of them that I ran the ideas by and the planned features before we had actually attempted it, and just kind of talked to them about what they thought they would pay for something like that. And believe it or not, stunt riding is kind of like the poor man's way into motorcycling. Like the track is a lot more money. Like stunt riders don't really have a lot of money, so we figured with a $50 price point, we could get more riders into the system, and that would be the main thing, is like getting it on more people's bikes, just to grow the ecosystem basically. So we preferred a lower price point, but we
And
still make, I think it was like a 52% markup over cost at $50.
that's one-time
Thank you.
charge. The $50, it's one time, right?
Yes, yes. So
One-time
one time.
charge.
And
Okay.
we had explored as options of like future revenue as some type of subscription based thing, but we
Can I
don't
talk a
have
little
anything.
more about that, about the future revenue?
Yeah.
So right now it's one-time cost $50 to actually get the device. That's version 1. Once we start going to more versions and actually having more, like Christopher was saying, like how much fuel you have, a different sensors that we can tap into your bike just because you have a custom bike. That's why you're kind of doing these kind of stunt rides. Going there, I guess that would be premium features, right? And so that's when we'd go into a model of you could pay more to have these premium features that we can also have. But for $50 just to get the device, you just have that. So it's more like options you can get when you're ordering it, to say, I also wanted to do this and that. And then from there, we'd have options on the box that you can connect to.
Hmm. Okay.
I
Thank
have,
you.
oh,
Yes.
are they done? I just wanted to know what would happen if the guy on the bike did a backflip. Would the accelerometer be able to recognize that and reset back to 0, or would it like read that as like a new normal, like way up above your x-axis there?
So I believe it would just roll over and even back out.
Okay, cool.